Okay, one way to graph that I don't think you're going to want to do very much, but it's your backup plan. It's something you can do all the time, is to remember how to take these numbers. That's the wrong one, isn't it? Let's do that one. Isn't that your number one? Okay. Is to take these numbers. This 3 stretches the what? The y's, right? So it's 3 times our y's minus 5. You don't have to do this if you don't want to, because most of you are not going to want to graph this way, but it's a good visual. Now, on the x's, remember that we have the reciprocating. The x's all get multiplied by a 2, correct? And then what? A 1 added to them. Y'all can't talk out loud even though I'm recording. Do you, everybody remember how to do this? To get these numbers and make this little table? Yes? So then you take, this is a log base what? It's not a log. It's an exponential with a base of what? 2. So the parent, this is the parent function. So look on your back of your packet you just filled out. What were the numbers for the table with the parent function of 2 to the power of x? Weren't the x's negative 2, negative 1, 0, 1, 2, and then I believe we have a fourth, a half, 1, 2, and 4. So then all you have to do is take this. What is 2 times negative 2? Negative 4 plus 1 is negative 3, correct? What's 2 times negative 1? Negative 2 plus 1 is negative 1. Did I do something wrong? 3 times y minus 5. Yeah, that's a y. Okay, so then we do 3 times the fourth minus 5. This is why, one reason this method's kind of yucky. You'll get those fractions. Okay, it's 3/4 minus 5. And you can use mixed numbers if you want to, because we're graphing them. So this is 3/4 minus 5, which would be what? Negative 4 and a fourth? Somebody correct, get me on that. That's right, isn't it? Yes. This is 3/2 minus 5. What would that be? 3/2 is 1.5, isn't it? 1.5 minus 5 would be negative what? Negative 3, 2.5, 3.5. Yeah, 3.5. I don't care what version you use. There's a decimal for you. 3 minus 5 is negative 2. 6, 1, 12 minus 5 is 7, right? So now you just graph your new points, which are not these. So now I have my new points. Negative 3, negative 4, and a fourth. Negative 1, negative 3.5. What's the next one? 1, negative 2. 3, 1. And 5, 7. So really, that wasn't so bad. But I think you'll like graphing without. Now, one thing you have to do to get full credit is dash in your asymptote. Where would the asymptote be here? Everything got shifted down 5, right? So your asymptote is going to be 1, 2, 3, 4, 5. And you always need to have your the asymptotes dashed in for credit. Where's the asymptote on a log? Vertical, right? So you are welcome to do it that way. Now, how do you do it if you don't want to have to use the table? Ready? We got plenty of time. This is what I would do if I were not going to use the table. I'm going to leave it there and so we can look at it. I first would set my asymptote. Asymptote goes down 5. And so I'll have that done. Then I put, it's kind of like a ghost point. We kind of used ghost points last year. And it moves over how many? One to the right. One to the right. So on my asymptote, one to the right, I'm going to put this open circle. And that's kind of my new origin. It's kind of the new origin where they would cross here. I just moved it around. Okay, so that's kind of where the origin would be with these transformations. Now all I have to do is take my, I really just have this left. Do you agree? Right? So then if you want to use your table in a different way, you can use your table and it makes a little bit better. Okay, again, my numbers were -2, -1, 0, 1, 2. And now all I have to do is multiply those by 2 because I've already gotten my ghost point set at shifted over. And my y's I just have to multiply by 3. What were they? A fourth, a half, 1, 2, 4. So if I just multiply these by 2, and you really can kind of think about it. 4, what is this? That's -4, isn't it? -2. And you'll get to where you can do this without making a table at all. Okay, let's finish this out. This would be what? 3/4, 3/2, 3, 6, 12. Agreed? Okay, so then all you have to do from your ghost point is go 4 to the left, 4 to the left, and 3/4 up. Look at it. 1, 2, 3, 4 to the left, and 3/4 up. You see it? Then this one's what? 2 to the left, 1.5 up. Do you see it? So it just makes it a little bit easier. And honestly, I'm good if you just use that much of your table. If you just use these, I'm fine with it. Okay? So if you want to do it like this, and you'll get to, I promise you, where you don't need to show all this work, where you'll be able to do it in your head. Yes? That's from this. So the question is, where did we get the hole, the ghost point? It's just a ghost point. It's not really a hole in the graph. It's just a ghost point because it's on my asymptote. It's not, it doesn't exist. But I went down 5 and to the right 1. And that just shows me where kind of where my vertex would be. If you would rather, instead of putting a ghost, just kind of put like a vertical there and show that that's your like your new origin. If you want to do it that way. Okay? Everybody go to this one. Is that the next one? No. Now, what's the difference in this one? What's its base? A 3, right? A 3. So when I get my table values, I have to use what? Do we have a table with 3 to the power of x? We don't have that one on the back sheet, do we? Where is it? Is it in the middle? Oh, no, it's on the front. 3 to the power of x is on the front. So you just have to make sure you use -2, -1, 0, 1, 2. What is this one? Isn't it 1/9, 1/3, 0, 3, and 9. And again, I don't really care if you use those 2. If you just want to use those middle 3, you'll be okay with it. Okay, we have 5 minutes, right? Everybody try to set your ghost point or your new vertex, new origin, new origin. I'm doing vertex in algebra too, so I keep saying vertex. We're doing parabola. New origin, where would it be? Up 6 into the, if y'all like it better if I just put a big, You can do that, or you can put the circle, whatever. I put it like this. I'll just put it in a different color. Okay. From there, what do I multiply all of my x's by? Careful. What do the x's get multiplied by? Is this y'all's? What? Oh, it's 1. Thank you. Right there. Doop. Thank you. Do we know what to put in front of the x, sleepy people? What is it? Can you see it on yours? Is this the same question you have? It's 1/2, isn't it? You flip it over. Negative, of course. What goes in front of the y's? Oh my goodness. Not one person knows what I'm going to stretch the y's by. -1. Okay? Now what do you do? And you can just be thinking this. You're going to get to where you just think it in your head and do it. But what does this give you? Okay, graph them from your new little origin. 1/2 to the 1/2 and down 1/3. So that is just right there, almost on the origin. 0 what? And then 1/2 to the left and down 3. 1/2 to the left, down 3. So that one is really steep. Okay, now when you do the logs, you're going to do it the same way. Just make sure you use the table of values for logs with the correct base. What is a log? What's the base if there's not one written? Base 10. Base 10 if there's not a base written.